So, like I said, we're doing factoring. We're going to be factoring polynomials. We're going to be stepping up above the quadratics we've been doing for the most part. Okay. The first ones you have here, the sum of cubes, the difference of cubes. Okay, sum of cubes is one perfect cube plus another. Difference is one perfect cube minus another. And you have formulas for factoring the sum and difference of two cubes. You must have this formula memorized by the time you take the test. Do not think, oh, well, I can factor it. I don't need to remember the formula. You cannot factor this without the formula. I've seen students try to, in great vain, to factor the sum or difference of two cubes, factoring the same way you factor quadratic. It does not work. You cannot suss out an answer. Either you have the formula memorized or you're getting it wrong. There's no middle ground on this one. There's none. You have to memorize this. So think about that when you're prepping for the Chapter 5 test and your skills test on that, or your lesson quiz when we come back from break. It's going to have this. Okay? You have to have these formulas memorized. Now, they're not that hard. I have a number cubed, or an object that's cubed, plus another object that's cubed. Okay? So I have a cubed plus b cubed. When I factor that, I get a plus b, same sign. And then I get a squared minus the two objects multiplied plus the last one squared. The big thing to remember, or I should say, and if you look at these two formulas, they are almost exactly the same. They're almost exactly the same. The only thing difference between the sum of two cubes and the difference of two cubes is the pluses and minuses. Now, I'm not much for acronyms. I'm really not an acronym person. But there's a very good one that will help with this. So, same, opposite, always positive. Okay. Same sign, opposite sign, always positive. Same sign, opposite sign, always positive. Other than that, the two formulas are exactly the same, except for the signs in between. And do not even think about factoring the quadratic that's left after your first thing. This quadratic portion here is unfactorable. Period. It's been proven. You cannot factor these quadratics that are here. This is the only, if you have the sum of two cubes, difference two cubes, this is it, you're done. Don't try to do the quadratic portion. You cannot do it. It is unfactorable, ever. Irregardless of what the numbers are. And a cube is any variable raised to a power of 3 or a power divisible by 3. And then numerically, you need to know some of your cubes. You should know by heart certain values. You should know all the perfect squares from 1 squared through 15 squared. It is immeasurably, it is essential to being able to factor things very well is to know your squares. 1 squared, 2 squared, 3 squared, so on, 1 through 15 squared. Your cubes, 1 through 5 are essential, and you should know 6. Okay? So 1 cubed is what? 1. 1 to any power is 1. That's the easiest one there is. But a lot of students, they see 1. 1's not a perfect cube. Yeah, it is a perfect cube. Okay? 2 cubed is 8. 3 cubed is 27. We're getting fewer and fewer answers. 4 cubed is 64. I got at least one kid that knows that one. 5 cubed? 125. And are you using a calculator?
Yes, sir, I am.
Oh, you're cheating.
No, I'm not.
6 cubed is?
216.
216. If you play Yahtzee on a regular basis, you know the odds. If you get 2 numbers that are matching, what are the odds of rolling the next 3 to get Yahtzee on one roll of 3 numbers to match the other 2 you already have? It's 1 out of 216. I know.
Played a lot of Yahtzee.
Don't ever play with my sisters. They'll kill you. They'll tear you up one side and down the other. Okay, we are currently, for time purposes, going to skip these problems here. These problems here are strictly review of factoring. However, like everything else in your note packet, you are still responsible for them. My TA will make sure that everything is done. He will look for these. But these are just review problems from things we've been doing. For time purposes, we're going to skip to the new material, which is next. Okay, factoring each perfect cube. The main thing, or I should say the first step to factoring two cubes, is identifying the two things that we are cubing. When you look at this first problem, the first thing we're cubing is easy. We're cubing W. Okay, what's the second thing we are cubing? 5. Okay, so I have W cubed and 5 cubed. And it's the difference of two cubes, right? So we're going to use the formula for the difference, which is, like I said, nearly identical. So I get W minus 5. And then my first term is W, so I square it. Then I multiply the two numbers. W times 5 gives me 5W. Remember, write it in the right proper order. And this one's minus because these two need to be the same. Okay. Or no, sorry, it's plus. This one's the same. This one's the opposite. And the last one is plus. I take 5 and square it to get 25. Same, opposite, always positive. The first factor, the sign is the same as our original problem. The next one is the opposite of what our original problem is. The last sign is always positive. Okay. 8h cubed. What are we cubing to get 8h cubed? 2h. We're cubing 2h. What are we cubing to get 27? 3. So I know the two objects I'm cubing. I plug it in my formula. This one's the sum of two cubes, which means my first factor is 2h plus 3. Same sign as my original problem. Okay, my first term in the second factor, I take the object I'm cubing, the first object I'm cubing, 2h, and I square it. I take 2h and I square it, and I get 4h squared. Multiply those two things. 2h times 3 gives me 6h. And because that's positive, this is negative. And then it's always positive at the end. And then take my last number and I square it to get 9. What's the first thing I'm squaring here? Or cubing, sorry. 1. What's the object I'm cubing to get 27a cubed? 3a. So my factor is 1. First factor is 1 plus 3a. And then my second factor begins with the first one squared, which is 1. And because my original problem is plus, this one's minus. Multiply the two. 1 times 3a gives me 3a. And then last term's always positive. And I take 3a and I square it. And I square 3a, I get 9a squared. That's my other factor. Okay, last one. First thing I'm cubing to get 64, I'm cubing 4. And to get n cubed, that's easy, that's n. So my first factor is 4 minus n. My second factor begins with 4 squared, which is 16. And then am I going to have plus or minus? Plus on this one. Multiply the 2, get 4n. And then the last one's always positive, and I square n to get n squared. If you know the formula, it's not hard. If you don't know the formula, it's impossible. It really is. This is one you have to know the formula. You don't know the formula. Okay, there's another way to do it, maybe. It involves long division. And you have to make sure that you get the first thing right. And it really sucks. Trust me. Okay, do those 4. Okay, hopefully that was enough time. So we have v cubed minus 3 cubed. So v minus 3, v squared plus 3v plus 9. The next one is 2 cubed plus 5b cubed. So I have 2 plus 5b. Gives me 4. This one's plus, so this one's minus. And then 2 times 5, that gives me 10b plus 5b squared is 25b squared. Okay. For this one, I'm cubing 3 and 2k. So I get 3 minus 2k. And I get 9, multiply the 2, gives me 6k, and this is a plus 6k. And then last one's always positive. 2k squared is 4k squared. I should say when I square 2k, I get 4k squared. Okay. And the last one, I'm cubing 1. I'm cubing 4h. 1 plus 4h. 1 minus 4h plus 16h squared. Okay, questions? All right. Factor each 4th degree trinomial. So previously, when we had 4th degree polynomials, we factored out something to make it a smaller degree polynomial. So I can't do that here. However, a 4th degree polynomial, this looks an awful lot like your typical quadratic, right? What's the difference between this and your quadratic? Powers are doubled. Which means I factor this one just like I would a quadratic. I factor that one just like I would a quadratic. So I get 2 numbers to multiply, give me 16. That subtract to give me negative 8. Negative 4, negative 4. Okay. Now, normally I would write this as negative 4 squared. Not going to do that here. I want to keep them separate, and you'll see why in a minute. So I get x squared minus 4, x squared minus 4. Because I didn't start with x squared originally, I started with x to the 4th. So that means my factors are going to be x squared, half the power. Okay, does that make sense? Do you see the connection between what we did before, the quadratics, to what we're doing here? Powers are doubled. Instead of x squared, I've got x to the 4th. Instead of x to the 1st, I have x squared. So instead of having x here, I have double that, which is x squared. Now, can I factor these? Yes, I can. That's what we're going to do, because we're not done. We've just one step of factoring. So, difference of 2 squares. X is x squared, 4 is 2 squared. So when I factor x squared minus 4, I get x minus 2, x plus 2. Difference of 2 squares. When I factor x squared minus 4, I get x minus 2, x plus 2. And I am just fine with this being the final answer. However, if you want to be cute and neat, you can say that, oh, that's x minus 2 squared times x plus 2 squared. Because that's really what I have, right? So I have an x minus 2 and an x minus 2. Got 2 of them, so they're squared. Just rearrange things. You don't have to write them that way. If you want to leave them like this, this is perfectly acceptable for me. Yes? No, because this is x plus 2. Okay. So let's take a stab at the next one. Two numbers to multiply give me 36 that add to give me negative 13. Did I write it wrong? What? No. Yeah, you're right, I did. My bad. Okay, that's 2 mistakes today. That's not bad. Counted them all yesterday and I did 5 altogether. Thank you. Okay, two numbers multiply give me 36 and add to give me negative 13. Negative 9 and negative 4. Okay, so that means I have x squared minus 4 and x squared minus 9. Well, we've already factored x squared minus 4, right? We did that here. In fact, we did it twice here, didn't we? Difference of 2 squares, x squared and 2 squared. X squared minus 4 is x plus 2, x minus 2. If I look at x squared minus 9, I have the same thing. X squared minus 3 squared. So it'd be x plus 3, x minus 3. This will not always happen with everything, but these ones are designed to have that happen. Sometimes you can't factor the next one. If this wasn't a perfect square, let's say this was x squared minus 5, I'd be done. Let's say this is x squared plus 4, I'd be done. But because it's a perfect square minus a perfect square, I can go that next step. Okay, you should always check to see, can I go that next step? Sometimes you can't, sometimes you can. Okay. Two numbers that multiply to give me 9 that add to give me negative 10. Negative 1 and negative 9. So that means I have x squared minus 9, x squared minus 1. Oh, and look, we already know how to factor half of that, right? Because we just did it. X minus 3, x plus 3. That's the x squared minus 9. And what about x squared minus 1? Is that the difference of 2 squares?
Yes.
1 squared is 1. 1 cubed is 1. 1 to the 4th is 1. 1 to the 5th is 1. 1 is always 1 to some power. 1 is 1 squared. That's x squared minus 1 squared. So it'd be x plus 1, x minus 1. Okay. Your turn. Okay, so the first one, two numbers multiply to give me 25, add to give me negative 26. It's really easy when they're 1 apart. When it's 1 more, then it's 1 in the number, right? 26 is 1 more than 25. How do I get it? Ooh, 1 plus 25. So I get negative 1 and negative 25. So I have x squared minus 1, x squared minus 25. And as we remember from previously, yes, 1 is a perfect square. So we get x plus 1, x minus 1. And 25 is 5 squared. So we get x plus 5, x minus 5. On the next one, same idea. Multiply to give me 4, add to give me negative 5, negative 1, and negative 4. X squared minus 1, x squared minus 4. We've done both of those. That shouldn't be too hard. x plus 1, x minus 1, x plus 2, x minus 2. And then the last one, multiply to give me 100, add to give me negative 29. Negative 4 and negative 25. You should be thinking when you see these problems, ooh, they should be two perfect squares. Are the numbers I'm adding and multiplying. That should kind of help give you a clue where to go on this. So x squared minus 4, x squared minus 25. So I end up with x plus 2, x minus 2, x plus 5, x minus 5. These are special ones. Okay, they are fourth degree trinomials. X to the fourth, something, x squared, something. In fact, their first factoring is just like factoring quadratic. Because these were all difference of squares after that, they were factorable again. If they're not difference of squares, they may not be factorable again. We won't know, we're not sure. But we always want to check and see. Okay. Okay, next one. Factor each third or fourth degree trinomial. These are a little different. Upon first glance, oh, there is a variable in every term. So what should I do? What should I do? Pull out the common factor. Pull out the common factor. When you're factoring and you're not sure what's going on, or if you see something the same in every term, pull out the common factor first. So in this one, my common factor is x. Pull out x. 3x squared plus 5x plus 2. And then see, oh, can I factor the remaining quadratic? And you give it a shot. Multiply to give me 6, add to give me 5. 2 and 3. But because I don't start with 1 in the front, I need to divide both of those by 3. So my factors are 2/3 and 1. So I get x. Do not forget the x that you pulled out. Very, very common mistake. You forget what you've already factored out. Okay, just because you already pulled it out doesn't mean it doesn't still belong. It just got to get out early. And then 2/3 means I have 3x plus 2. And then I have x plus 1. Next one. What's my first step? Pull out the y. So I get y times 2y squared minus 5y minus 3. Ooh, a little different. Two numbers that multiply to give me negative 6 that add to give me negative 5. And negative 2 and negative 3 ain't going to work. 6 and 1. Negative 6 and positive 1. Divide by the 2 that's in front. So this one reduces to negative 3. So I have y minus 3, 2y plus 1. And the last one, what am I going to pull out? W squared, because I have squared. Pull out the smallest. I pull out the smallest power that's there because that's the largest thing I can pull out. Pull out w squared, and I'm left with 2w to what power? To the second power. 2w squared plus 5w to the first minus 3. And I get w squared times, and set it up one more time with negative 6, and this time positive 5. Excuse me. 6 and 1. And 6 and negative 1. Divide them both by 2. And I get 3 here. Or sorry, and I get negative 1/2 there. So I get w plus 3, 2w minus 1. I want you to notice something. On every one of these, I should say, Yeah, every one of these, 5 is the constant, 5 is the b in the middle term, and 2 and 3 make up the end terms. Notice they're all different factors. All depends on which ones are where and whether they're positives or negatives. The last two are almost identical. In fact, the only difference between the last two is you got a -5 and a +5 for your middle term. But the factors are different. Okay, it makes a difference what goes where. They're not the same problem, they're not the same answer. Okay. Now it's your turn. Okay, first one, factor out a d. I'm left with 3d minus 3d squared minus 7d plus 2. And I end up getting, let's see. So 6 and 7, 6 and -7, -6, -1. And divide by 3, so I get -2 and 1/3. So I get d times d minus 2, 3d minus 1. Can't quite do that one in my head. Okay. Next one, the penultimate problem. Look it up. B times 2b squared plus b minus 6. So I have b plus 2b and b and plus 2 minus 3. Is that right? Yes, I did it without doing the Xbox. It's been a while since I've done that. I'm happy I could do that one in my head. I don't expect you to always do that. I really, really, really like this. This makes it so much easier. But it's been a while. I wanted to try to do it in my head. So I'm happy I got it right. Well, yeah, like I said, it's one of those things. So factor out a c squared. 3c squared plus 8c minus 3. So I get c squared and 3c and c plus 3 minus 1. Yes, that'll do it. Is that right? Does that match what you guys got?
Can you do the middle one?
-12 and 1. So that'd be -4 and, sorry, +4 and -3. And that's a 2, so I divide by 2. Divide by 2 and I get 2. So b plus 2, 2b minus 3. Okay. On the other one, you'll have 8 in the bottom and 9 on top, which is 9 and 1, -9, so it's 9 and -1. Divide by 3, that's what you end up with. Okay. Questions? Okay, so you have 2 worksheets.